Hi friends, today we are going to study about balancing of redox reactions in basic media, and I am using half reaction method to solve this question. So here you can see a question like MnO4 minus plus I minus gives MnO2 plus I2. Let's do this balancing in basic medium by half reaction method. So first of all we'll write the oxidation state of all the elements. As we know that oxygen is -2. When you solve manganese as x minus 8 is equal to -1, x is equal to +7. This is the normal basic method of finding oxidation state. And here iodine is in -1 oxidation state, but in the right side it is in +0 oxidation state. Here oxygen is -2, so to neutralize that, manganese is in +4 oxidation state. So this is the basic method to find the oxidation state. Now we can compare. Manganese is changing its oxidation state from +7 to +4, which is a reduction. Why? Because oxidation state is decreasing. And iodine is changing its oxidation state from -1 to 0, and it is undergoing oxidation. Why? Because oxidation state is increasing. So now let's divide the reaction into two reaction half, like oxidation half and reduction half, which is the first step of balancing. I minus is giving I2, that is the oxidation half reaction. MnO4 minus gives MnO2, which is the reduction half reaction. This is the first step of balancing. In second step, we have to balance the atoms other than oxygen and hydrogen, except oxygen and hydrogen, which is iodine in oxidation half. So to balance this iodine atom, let's give 2. 2I minus gives iodine. Now iodine is balanced. But in reduction half, manganese is one time in LHS and one time in RHS as well. So no need to do anything in the second step of reduction half. Step number 3 is balancing oxygen. To balance oxygen, add equal number of water molecules in the opposite side. But there is no oxygen in the oxidation half, so we don't need to make any change. But in reduction half, MnO4 minus, it means 4 oxygen atoms are there, but in reduction half only 2 oxygen atoms are there. So to make it balanced, we have to add 2 water molecules in the right side. So whenever you provide water, we are providing hydrogen as well. So because of hydrogen, the number of hydrogen atoms become 4H. To make hydrogen balanced, we need to provide equal number of H plus ion. So that here we are adding 4H plus in the left side. So now H plus ions are equal. Both hydrogen and oxygen ions are equal in both reduction and oxidation half, which is step number 4. But in oxidation half, you don't need to make any change because there is no oxygen and there is no hydrogen as well. So till now we have balanced all atoms like iodine, oxygen, hydrogen, etc. Now in step 5, as the reaction is proceeding in basic medium, we need to do something more which is different from acidic medium. An extra step is there. What is that extra step? Which is when you add H plus ion, here we have provided 4H plus ion. As the reaction is in a basic medium, we need to provide equal number of OH minus ions in both the sides, both LHS and RHS, not only in one side, both the side we need to provide OH minus ions. So here I have added 4 OH minus ion in LHS and RHS. But here also in oxidation half there is no change because of the absence of H plus ion. Now in next step, let's see what is happening, which is H plus and OH minus ion makes water. We know that. So here 4 H plus and 4 OH minus ion. It makes 4 water. So I'll just write 4 water over there. 4 water in the LHS. And that 4 water will cancel with 2 water in the RHS. It makes 2 water in the LHS. 4 minus 2 becomes 2. So we can write here 2 water. It gives MnO2 plus 4OH minus. So this is the difference between acidic and basic medium. Here one extra step in the form of adding OH minus ions. Now the normal step only. Till now we have written in the oxidation half. Here I will write it again. We wrote 2I minus gives I2. This is what in the sixth step of oxidation half. Now we'll balance the charges by adding electrons. Here we can see 2 into 1 minus. It makes minus 2. And in the RHS 0. So to make the charges equal, what we need to do is, we need to provide 2 electrons. As the electrons are negatively charged, we provide 2 electrons in the RHS. So it becomes minus 2 in both LHS and RHS, which makes a seventh step. Now, here I'll show you the charges in the reduction half. Here 1 minus. Here water is 0 because there is no charge over there. It makes 1 minus in the left side. Here MnO2 0 and 4 minus. It becomes 4 minus. Total becomes 4 minus only. And the difference between 1 and 4 is 3. It means 3 electrons to be added. To where we need to add electron? To where there is less negative charge. Less negative charge is there in the left side. Because 1 minus only in the left side. If you are adding 3 more electrons, become 4 minus will be the charge in the LHS. So the seventh step will be like this. MnO4 minus plus 2H2O plus 3 electrons gives MnO2 plus 4OH minus. So electrons are balanced. But still some issues are there in the form of number of electrons. In the oxidation half it is 2 electrons, but in the reduction half it is 3 electrons. So to make the electron numbers equal in both oxidation and reduction half, what we need to do is, we need to multiply oxidation half reaction with the 3. So it becomes 6 electrons. Similarly, reduction half reaction with the 2. So there also 6 electron will come. So the overall reaction becomes 6I minus gives 3I2 plus 6 electrons. And reduction half becomes 2 MnO4 minus. We are multiplying with 2 all the species. So that 4 water plus 6 electrons gives 2 MnO2 plus 8 OH minus. So electrons are equal. Now we are going to take the overall reaction by adding both left sides of oxidation half and reduction half and right sides of oxidation half and reduction half. So it becomes 6I minus, that is the only species in the left side of oxidation half, plus left side of reduction half is 2 MnO4 minus plus 4 water. And we don't need to write 6 electron. Why? Because it will be cancelled. Which gives 3I2. I2 is the oxidation half right side. Plus 2 MnO2 plus 8 OH minus. So this is the overall balanced equation. So now we can verify by checking the number of atoms, whether it is equal in LHS and RHS, and also we can check the charges, whether they are equal or not. This is the overall reaction. Thank you.